Good day. Welcome once again to our asynchronous class in quantitative methods. In this video lecture, we will be having a review on measures of central tendencies. I know these three central tendencies are not new to you because, of course, you have met or you have familiarized yourselves with these central tendencies, the mean, median, and mode. Okay, so let us discuss first the mean. Okay, we know it very well that the mean is the most commonly used measure of central tendency. It is sometimes called the average. Let us have this example here. We have these two football players. They are Sosa and McGuire's. Here we have the list of their performance rating per year. So we have Sosa and McGuire. So we have the list here of Sosa, which has 13 data or 13 years of playing football. So in finding the mean, you're just going to simply add all the data that you have, 8 plus 33 plus 25 plus 36 plus 40 and so on, and then divide it by the total number of data, which is 13. So we can count it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so you can use calculator so that you can add it easily. And again, we are going to use Excel in adding this so that you can make your computation faster in our next lessons about softwares. So this one, you will have 545 and divided by 13, you will have 41.92. This is now the description or that single description of the entire career of Sosa as a football player, 41.92. While we have here McGuire, the same process we add, we sum up all the scores, all the ratings per year, and then divide it by the total number of um, data, which is 15. So 580 divided by 15, that is 38.67. This once again sums up the career of McGuire as a football player. So we can compare the two now. 41.92 for Sosa and 38.67 for McGuire. Therefore, Sosa is better player than McGuire based on the data that we have. Yeah. And sometimes we have this so-called outlier. This can destroy the performance of, or let's say, the description, how you describe the mean. For example, in a class, you have this score here. Most of your pupils are performing well. They have scores from 80, 90, 92, 100, and so on. So, and then you have this one student there who has a score of 30 or 20, very far from the other data. That is what we call the outlier. Sometimes it can destroy the meaning of the data which we are describing the entire performance of the class in that example. That is what we call outlier, extreme relative to the data. How about weighted mean? Ayan. So let us have this example for weighted mean. So the following are Hosilitas grades for the third quarter. So we are going to find the general weighted average. So this example, you can relate to this one, especially in college, that you have units. For example, in theology, you have, I think that is only one unit. And then for PE, that is 2 units, I guess. And then for major subjects, you can have 3 units. Or for practice teaching, or I mean, for practicum or OJT, you can have 6 units, and so on. So not like before, when you were in elementary, your teachers only add up all your grades per subject and then divide it with the total number of subjects. Here we are considering the units, the weight, okay? The weight of the subject, because of course we need to consider this subject is um, hard, and then this subject may be not that hard, you only meet once a week, something like that, okay? So we have here the units, 3 units for math. As you can see, English is 2 units in this example only, okay? And then Araling Panlipunan is 2 units. And then we have the grades, respective grades. And then for us to find the mean is very simple, the weighted mean, okay? So you're just going to simply multiply the grade times the unit, which is 3. So units is 3, and then grade is 89. So multiply x times u. 89 times 3, that is 267. The same process that you're going to do here, and so on. And then you're going to add another column. You're going to divide it by the total number of units, which is 12. Okay, so you have 267 divided by 12, that is 22.25. Another 168 divided by 12, that is 14. And so on. And then you can now have the final answer. Weighted mean is equal to 87.08 hundredths. You're just going to add all these sums here, or let's say the quotients here, and then you'll have 87.08 as your weighted mean. This goes to many examples, not just in grades, okay, in many more examples. That is the weighted mean. Another example is the group data. So how to find mean in a group data? The example that I gave you here about the football player, this is ungrouped data, while in this example is grouped data. Okay. In group data, you need to use the frequency table. The first lesson or video lecture that you were able to watch with me, um, we are going to use the frequency table or the class intervals first. So given, you're already given with the class intervals, and then you also have the frequency. So you have 2, 9, 15, 20, 17, 25, 2, and 1, and so on. So you have here the midpoint. You already know how to find the midpoint. You're just going to add 1 plus 5, that is 6, divided by 2, that is 3. The same process here, 6 plus 10 divided by 2, that is 8, and so on. And then we are going to multiply the frequency by the midpoint so that you can have this column for you to find the mean. So 3 times 2, that is 6. 8 times 9, that is 72. And so on. Sum it all up, you will have 1,828, and then divide it by the total number of frequency, which is 91 in this example, and then you will have 20.1. Okay, so the mean for this example is 20.1. Okay, it is somewhat evident in this example because you have the frequency here. Okay, the frequency table. Next, the second central tendency, median, or what we call the middle score. We have the formula here. D is equal to n plus 1 over 2, and then the median is MD is equal to X sub D. Do not worry much about the formula. Okay. In this example, we have the research. For example, this group of undergraduate students in 2016 decided to have a research on the number of households in Bantayan Island. Okay, the household size. For example, this is family Number one, they have the size of 7. That includes the family members, maybe your father, mother, sister, brother, another brother, you, and then another brother, and so on. So that is example. And then this is the total monthly income, and so on and so forth. So the question only is we need to find the median of the household size of this data set. So we have this data set here, size only, the size. So we are going to list it all. Again, median is the middle score, the middle term. So in order for you to find the middle term is you need to arrange it ascending order, or you can have descending order. 3 is the lowest, 10 is the highest. Okay, ascending. 3, 4, 4, 4. Again, this is from this data that we have. Okay. And then you can now apply the formula, which is D is equal to N plus 1 divided by 2. N is the total number of data that you have, plus 1 divided by 2. And then it becomes 16 over 2 or equal to 8. Okay, so 8 here is not the median. 8 is only the position of the median. So you can count 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the median is equal to 7. And even if without this formula, you can easily count it. You can merely count it. You can arrange it, and then you can find the center. That is what we call the median. How about we are asked to find the median in a group data? This is another complex one. So group data in median. First step is you need to familiarize this formula. You need to use this formula so that you can find the median. Okay. So you have median is equal to LM, or lower boundary of the class median, plus so on and so forth. Later on, we are going to familiarize all these um, parts of the formula. Okay, let us have this example so that we can familiarize the formula. Okay, so we have example. Based on the group data below, find the median. This is time to travel to work and the frequency. So this is class interval from 1 to 10, 11 to 20, and so on. Okay, so you have the frequency and the class interval. First thing that you need to do is to add another column for cumulative frequency. Okay, you know how to do it? 8, this is the lowest, plus the second frequency, which is 14, that is 22. 22 plus the third frequency, 12, that is 34, and so on and so forth. And then you will have 50. Now, let us find the parts of the formula. N over 2 is what we call the class median. Yan, the class median. So, ayan, this one. The N over 2 in this formula. So, we need to find the class median by having the total frequency over 2. So, 50 over 2. Pila ka buok ang data? 50. So, you have total frequency 50. So 50 over 2, that is 25. And then F, what is this F? F is the cumulative frequency before class median. So since we already found the class median, which is 25, then we can say that F, or the cumulative frequency, which is before the class median, is equal to 22. Okay, so take note. Take note that we already found the class median. This is the center, since we have computed that 25 is the class median, and the class median should not be less than the cumulative frequency. It can be itself, equal to itself, or greater than. That is why we chose the 34, not the 22. Okay? So again, the class median should not be less than itself. It can be equal to itself and greater than to itself. That is why we have chosen this class interval and then the class median, which is 34. And since we already have the cumulative frequency or the class median, we are going to find the F, ayan, which is, again, the cumulative frequency before the class median. This is 22. And then Fm. Fm is the frequency of the class median, which is aligned here is 12. And Lm is what? Lm is the lower boundary of the class median. Lower boundary. Again, we have this lower boundary, higher boundary or upper boundary. And just a review, when you are going to find the class boundaries, you are going to subtract 0.5 sa lower boundary and add 0.5 sa upper boundary. Since we are only asked with the lower boundary, so we are going to have 20.5. 21 minus 0.5, that is 20.5. And the last one is the interval or the class size. This one here, 1 to 10. You're just going to count 1 to 10. That is 10. The same also here, 21 to 30, that is 10. 31 to 40, that is 10. That is what we call the interval. Okay? 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So you have I is equal to 30. So I hope you were able to understand so far. I really made it that detailed so that you can really understand well the lesson. How about this one? Median. Okay. We have now the formula and we already also have the parts. The lower boundary, we have the class median, 25. We also have the F, the class accumulative frequency before the class median. And then we also have the 12, which is the frequency aligned to the cumulative frequency. And then we have 10 as our interval. So perform it using the PEMDAS, of course, so that you can arrive at a correct answer. So first answer the operations that are inside the parentheses. So 25 minus 22, that is 3 divided by 12. So you will have that answer there. You can use calculator. And then the quotient of this, you're going to multiply it by 10, and then you're going to add it by 21.5, and then you will have the answer of 24. Okay, you can use calculator in solving this one. And again, do not forget to answer it using the PEMDAS. Next, 25, ayan, you now have the interpretation, okay, which is the median is 24. Okay, so the last one, finally, is the mode. Ayan. For me, mode, of course, for all of us, we we can conclude that the mode is the easiest because it is the most frequently appearing number or datum, or let's say the category. Ayan. For this example, we have identified the mode. Okay, in this set here, set of data here, we have repeating of 3. There are 3 threes. So this is now the mode. And as you can observe here, we also have repeating number, which is 5. It only repeated twice. So we have a great higher amount or higher number, which is 3 times. Therefore, we're going to have this mode, not the twice. Okay? So 3 is the mode, the most frequently occurring datum. Next is this part here. So it occurs twice, and you also have another one here twice. Therefore, you have two modes. And then this doesn't have a mode since, okay, it no repetition. And we also classify them according to its repetition. You have single modal, bimodal, trimodal. Single modal if only one number is repeating. Bimodal from the word bi or twice if there are two numbers that are repeating. Yeah, in this case twice. Trimodal if there are three. So you have 2, 5, and 8. 2, there are twos, there are two fives, there are two eights. And that's it. You have single modal, bimodal, trimodal. And this is the last one. Last example. We are asked to compute the mode using the grouped data. We have now again the, what is this? Class interval. Okay, so we are also given the frequency. First thing that we need to do is to familiarize again the formula. This is already prepared to us by the statisticians so that we can find the mode using the group data. It is somewhat hard, but no, you can you can answer it if you are going to really arrange the data, all the data, but data in Excel, no need of having this um, class intervals. But sometimes we are given only with with this class interval and frequency, so we need to really, no, we need to really find the mode in this case. Okay. Though finding the mode in this case is really really not that much occurring. Okay, we do not encounter it that much. So we have here the parts of the formula, that is modal class is 26 minus 30. Why do we have this modal class 26 minus 30? Because from the meaning of mode, it is the most occurring frequency. So since we have greater or higher number of frequency here, which is 14, therefore we conclude that the mode is somewhere here. Somewhere here. 26 to 23. This is our modal class. And we have our lower boundary. 26 minus 0.5, that is 25.5. D1 and D2, in order for us to find, to really make it accurate, okay? So we have the D1 and D2. It is the interval between the class modal frequency and before and after, okay, after it. So we have D1 is 41 minus 7. Just subtract it, 41. I mean rather, 14 minus 7, and then that is 7. And then 14 minus 8, that is 6. And then the intervals of each class interval, or what we call the class size. 41 to 45, we are just going to count 41, 42, 43, 44, 45. There are 5. Okay? That is how you are going to compute it. And then, since you have already the parts of the formula, then you can now easily substitute it in this formula. Lower boundary 25.5 from here. D1 7, D1 and again 7, D2 6, interval is 5. And then use PEMDAS again, 7 divided by, 7 plus 6, that is 13. 13. So 7 divided by 13, that is decimal. And then times 5, that is another, maybe another answer. And then plus 25.5, you will have 28.19. See, 28.19 is somewhere in between our class mode or modal class, 26 to 30. It is in between here. Okay, that is how you find the mode using the group data. So those are just the central tendencies, the review on central tendencies. Because I know even though you were able to master it in senior high school, then we sometimes forgot, of course. We forget the formula. Ayan, formula most especially the formula. So let us sum it up. This is the mean. So the mean is just the average. You're just going to add up all the data and then divide it by the total number of data. And then the median, you can find the median by using the formula n plus 1 divided by 2. Or you can simply arrange the data ascending order from lowest to greatest, or you can have greatest to lowest and then find the center. If you have two centers, then you are going to find the mean of the two centers. Next is the mode. The mode is the most frequently occurring score or datum. Okay. Thank you so much and see you next time in our next video.